Hello, welcome to Learning Activity 2 this week. When you start this, you should open up this Colab notebook, and that should open up in Google Colab like before. So we'll get this set up in Google Colab. And it starts with just introduction with some preps. So a couple things: you should make a copy of this notebook for your own, because you won't be able to edit this original version of it. And once you make a copy of it, it's nice if you can put your name on it, because you'll be sharing and submitting this notebook later on. Also, you want to open up the write-up that associate with this, and this is just a Google Doc that'll open up. And again, you should make your own copy of this and have this and put it here. I like to put links back and forth between these, so I like to put a link in my notebook here to my write-up here, and then here I like to put a link back to my Colab notebook, because sometimes I'm opening up one and then I want to go to the other. And there are links throughout this, but again, this will always link to my copy and not your copy. So it's nice if you put in your links to back and forth. And then finally, you're watching this video here, which is the intro video of it. So we're going to look at how to use some of the main Python libraries for analyzing and visualizing data today. So we're going to look at some data from what the IRIS database, which is a really well-known database out there of data. So it includes some data of iris species here, and it's a data set of 120 measurements. And for this, they measured the iris flowers are made of sepals and petals, and so they measured the length and the width of the sepals and the petals. Here. So we have 4 measurements for each flower: the length of the petal, the width of the petal, the length of the sepal, and the width of the sepal here. So that's what we have, and you can look at some more. Some of these visualizations come from a Google walkthrough using the same database here. So again, the first thing we're going to do is set up our tools. So we're always going to run in section 0 these commands. So this is actually, here's our first, all this above this has been comments. Here's our first command we can run, and we can just hit run to run this command. And it will import the libraries that we want. So we're going to import a couple libraries. One is called pandas, and we're going to give that a nickname of PD. Seaborn is a graphics library, and that'll be labeled SNS here. So those are the main libraries we'll be using, is this, and the main one we'll be using is this panda one here. For this. We do turn off some warnings here throughout this, because sometimes there are different versions of these, and it sometimes confuses students to see an error warning here. But that doesn't affect this, because it's not a real error, it's just a warning. So this is all this does, is turn off some of the warnings that we'll get throughout this. Okay, now we're reading the data here, and again, I can run this command. Now, some students like to just start these notebooks and say run all, and run all the cells in the notebook, and you can certainly do that. I like to just go through this and either click one, run as I'm going through, and see if each one works, or you can also hit shift enter, and that'll run the cell and go down to the next cell below it. So what we have is we have this panda library out in a CSV file, a comma separated value file out there on the internet, and so we're set up a URL to that, and then we're reading that in using the pandas library here. This is a typical command in Python. We say PD is the pandas library, and then dot, and then the command read CSV, and then we might provide some arguments for that. If you've used the programming language R, that doesn't have any special. There, they sometimes use the dot inside variable names, but in Python and a lot of other languages, the dot is used between variables. You say a variable name dot, and then the method or the operator you want done using that variable here. So here we're reading the data in and storing it in this variable called iris here. Okay, so now let's open up section 1. Now, one thing you can also do is you can open and close some of these sections. So like section 2 is here, but it has 5 hidden cells. So I can unhide that or hide that. So here section 1 is here, and you might see section 2 is right here, but there's 6 hidden cells here. So I'm going to unhide that here and go through. So this walks you through some more details of what we're going with, a neat little tutorial about wrangling data with pandas, which I think is very good. And then here's our code. So here again is a new command. We're using the iris data, which we had created up here, this variable. And again, the dot, and then head is our command or our method, and then we have a parameter called 5, and this will print off or display the top 5, the first 5 rows in this data set here. Now you can actually play and run this code in different ways. So if I run this code here and do head, it displays this. Now the pound sign or hashtag, I guess you may be used to calling it, is a comment in Python. So see, some of these are in green, meaning they're commenting things out. So I could delete that pound sign, and I could actually add a pound sign here, and now it'll run this line rather than this line. So now if I run it, it'll do something different here. So one thing I want you to play with when you're working with this is, to uncomment some of these and see what they do. So what happens if we uncomment this? You can uncomment a couple of them and see what they do, although it's often nice to isolate them and just run one at a time and see what that does. Okay, so again, watch the video, try out some different commands here, try to learn what these different things do. One other thing besides just displaying things, we often want to select different rows and columns. So basically, again, we're working largely with something that looks kind of like a spreadsheet here. We have different columns and different rows here. And in fact, we have 151 rows and 6 columns. But we can then do things like we can select certain columns and certain rows with different commands. We can select columns both by their name here or by their numbers, and similar to rows don't have necessarily numbers, I mean names on them, but we always are selecting numbers with the rows. So here are some different commands that you can try out and see what they do. So I'm a little worried you're just going to skip over this and not do anything, and so that's what the write-up is for, of course. So task 1 is the write-up. So if I go over to task 1, here's the write-up, and this is going to ask you questions about some of these commands. Have you try out certain commands and put them here and tell me what the results are. So you have to actually do some of this stuff in the write-up that you'll submit for this thing. So that's task 1, is to go through these task 1 questions here. Okay, then we go on to section 2 here and run this and look at this. We're going to look at some of the anomalies in the data. Now the iris data, the original iris data, doesn't have any anomalies, so you are actually working with a modified version of it that I have created, which has at least one error in it for this. So we'll be looking at this data. Now we could certainly do this in a spreadsheet. This is a small data set. It only has 150 rows and 6 columns, which is easily readable by a data set. And so you might ask, why aren't we just using a spreadsheet to do this? Well, in machine learning, we often use data sets that are really large. So like a project we use at times is movie review data set, which will have 10 million movies, each tagged with 2,500 different tags. So that table is 10 million rows and 2,500 columns, and that actually will not open up into Excel. It's just too big, and so you have to use something like Python or a statistical language like R often to access that. So that's why we're using, we're doing some of this stuff you could do in Excel, but I want you to learn how to do it in Python here. Okay, so again, we want you to investigate this data in different ways. Look at the shape of the data, look for count the values here. Some of the values will be null, and so we'll talk about those values and how that works. So what do we really mean when we say some of the values are null? That means that they're kind of empty. So if let me just open this up in a spreadsheet so you can maybe visualize it. You may have seen this. So this is a spreadsheet version of this, and here's my data here. And if I scroll down, there are some of the data is empty, so there are no cells. The cell is just empty here. And so that's again what we talk about as a null value or an empty value here. So again, you want to isolate those. There's usually mean there's an error in that one, and often we just eliminate that row here. So again, in Excel, we would just maybe just click on here and say delete that whole row here. But how do we do this in Python? So you're going to have to look at how you do that in Python in different ways. So we'll look at removing the nulls, the null values here, and then removing some abnormal values. Now, so far we've been using this variable iris. So here is our command to drop all the non-numeric values, our nulls here. But we're going to save that in a new variable called irisclean. So we're moving from the original iris data set to a new variable which will have a cleaned up version of the data here, and then we'll see it. So now, where before we were often looking at, we'd say iris.info to get info on it. Now we are saying like irisclean.info because we've copied and modified the iris database to this new clean version here. And so again, there will be some abnormal values in here for this. So here's a graph of this chart. So again, once we've dropped out the null values, we'll look at some abnormal or erroneous data here, maybe caused by entering errors or some sort of error in the process. And again, I've introduced at least one erroneous value in this data set. Here. So some ways you can do this, you can just look at the largest values for certain things to see what those are and see if you see anything abnormal about that. Smallest values, you can look at the smallest values and see. So like here, this is looking pretty normal. The smallest value is 4.3, but there's a couple 4.4s, 4.5s here. Because we're just looking for the smallest. This command is irisclean dot and smallest, and here we're saying give us the 10 smallest values just using the sepal length column. So it kind of basically sorts it on the sepal length column and displays the 10 lowest values here. But again, this is lower than the others. It doesn't seem to be abnormally low. Whereas here, where we do the largest values, this line 13 here, the sepal length is 448, and the other largest value is like 7.7 or 7.9. So that's way larger here. And in fact, it kind of looks like there are values that will be 4.8 here. So maybe there is just an error in decimals, or somehow this was entered incorrectly. We don't know, but this seems really abnormal. So this is one we should get rid of. And also we can plot the data here. So if we do a simple plot of this data, we can see this one value which is really large here, where once we clean up the data, this display will be quite different. So this is what the plot would look like if we remove that one large value here. And again, it looks like everything's in common ranges or stuff. I don't see anything jumping way off of the screen or anything like that. Now, there are more complex and actually better ways of finding outliers or erroneous values here. And so as a bonus challenge, there are some discussions here about using standard deviations and z-scores to do that. But again, I'm not going to require you do that, so bonus challenge is optional, but I think you'd probably find interesting, but not required. Okay, so once we find some of these rows, you want to remove some of them. So this talks about some of the commands to remove these. Here we take our irisclean database, do some operation on it, and save it as a new version of the irisclean database for these. So these are the commands, and here's the actual commands you can run here to try out and display your data in some ways. And again, with this, you'll want to be going through the write-up. Task 2 write-up talks about how you can, where null values are, how you can count the number of sections, what this drop NA does, and things like that. And then task 3, which corresponds to section 3, talks about this new irisclean variable, and I want you to list which rows or which sections are flowers or rows, which abnormal data you dropped or removed from this in different ways. And there's a bonus challenge question here about the z-scores, but again, that's optional. So then we're going to get into visualization. Once we get into getting our data kind of cleaned up, which is kind of standard process in all machine learning things, is to first clean up your data. It also helps to kind of understand our data and how it works. So we're going to look at some visualization techniques here. So something to keep in mind is this, in a later assignment, and in fact what's commonly done with this iris data is a kind of an iris flower challenge, where looking at the data, can you predict what species these flowers are from. So if you remember, we have 3 different species of flowers here, of irises, and they all have different characteristics here. And then with our data, we have data on, again, the sepal length, the sepal width, the petal length, and the petal width of each flower. And then we also know what species it is. And then the question comes is, if you look at enough data, if your machine learning algorithm looks at enough data, can you figure out some statistical method or some other method of looking at a certain flower's measurements and then predicting what species it is here. And so that's what we're going to look at, or what we're going to keep in mind when we're doing these visualizations, is how we do this. So there starts with some simple plots here, and then the plots get more complicated here. And again, we're often going to plot different species of data with different colors or something like that, so we can kind of see. So here you might see, while this iris setosa values looks like they're pretty separate from these two, versicolor and virginica, are pretty mixed, and it would be hard to tell these. Now, what I want you to do is go through and then modify some of these plots. So let's talk about, let's start with the basic plot up here. So this is just using the iris data. We're just going to do a plot here. So one thing we do here is we take our data, we do a quick cleanup of the data, and then I rename this just as iris. So where we were using the clean data, once I get it all cleaned up in this section, I'm renaming it as iris. So in all of this stuff, we can just look at the iris plots here. So I'm just going to say iris and then plot and then the data here. This is the kind of data, and then here are different, we're plotting the sepal length versus the sepal width. So here's the sepal length and here's the sepal width up here. But we can actually change these values here. So we've got these different things. So if I want to plot the petal length, I'm going to grab the petal length here and go down here to the code. And rather than doing the sepal length, maybe I'll want to do the petal length here. And in fact, you can just everywhere there, any place where it says sepal, you can type in petal, and again, length and width can kind of be substituted also. And now I can run this code again and get a different kind of plot for this. Oh, and I didn't run this code up here because here's my outlier data here, so I forgot to run this code in order. So I want to make sure I run this code here and then run this code. And that's a better description of this. So again, in each of these, you can try to plot different values against each other. You can also try changing the size and see this works. And so again, in your write-up for each plot, I just want you to make some change to it. Change, instead of plotting the sepals, plot the petal or the width or the width or the size, some simple change on it, and then describe what the visualization shows in some ways here. And again, often we're going to want to try to figure out plots or show things where we can clearly identify one species from another from some of the measurements here. So again, you can go through these different plots and see how they work. Now, if you want to, these plots generally have names, and you can actually just Google those names to search for what those plots do in different things. What is a violin plot? If you're not familiar with it, or if it doesn't make sense to you, feel free to Google some of those in different ways. And again, we're not going to get too statistical of this, but these are just different ways of visualizing this data, these values here. And in fact, this pair plot, the last plot here, combines a number of these visualizations together in one large plot here. And as a bonus challenge, you can go out and find your own visualizations, especially with this iris data. It is the well-known kind of introductory data set for machine learning. And so there are lots of examples out there of visualizations of this. So feel free to go out there, find a visualization, a different way of graphing this, and posting code here and seeing how that does. So, okay, so that's your introduction to visualization and data manipulation in Python. Remember to submit, to share here the notebook. Either create a shareable link or share it with me directly here, and then same with the write-up. And then when you submit them, submit both of those. Remember now, you should be posting questions and stuff to the discussion areas. So look in the discussion areas to post questions, comments, or suggestions for other people.